Hello, and welcome to Apropos, a conversation between Clojure programmers that you can join in live on YouTube. We're going to discuss a few Clojure news items and share our opinions on them. Then we'll jump into a REPL and code some exercises or do some demos. If you're joining us live, feel free to comment in the chat, and we'll try to address the questions. So we have a full panel today. We have Mia.
Hi.
Mike.
Hello.
That's not Mond, it's Ray.
Mond.
And I'm Eric.
Hello.
How are you all today? Just want to say that there are show notes in the description. So those kind of just went in. So if you already had the page loaded, you might need to reload so that you can see that. Okay, let's get started.
I think that's the kind of like race condition we can probably deal with.
Yeah, just restart the browser, it's fine.
Do that all the time. Yeah.
Reboot your machine. Okay, so our first item in our show notes is a new JavaScript engine called Hermes. What is this all about?
I don't know. I just noticed it.
Who's making it?
Okay, so the few things that we do know is that it's made by Facebook, and it's evidently for Android to make React Native run faster. So there's like a tweet that showed that it starts up, that it's like lower latency startup of your React Native app.
Okay.
And the tweet that I saw showed it starting up some app in a matter of like 2 seconds instead of 4 or 5.
Oh, wow.
That's a huge difference. React Native is so much worse for Android than it is for iPhone.
Oh, really? Interesting.
Yeah, it's it's a lot of, especially small places, will choose React Native because they don't want to be running 2 different development teams for the same app.
We do that, yeah.
And porting React Native for iPhone to Android is actually kind of difficult. And the performance is not as good. So anything that Facebook can do to increase that performance is going to help. I think.
So does that mean it ships? You have to ship the JavaScript thing with your app, the JavaScript VM with your app?
Oh, that's a good question.
Yeah, so I did see, like, if you go to the React Native site, there's like some sort of opt-in flag, so they make it easy to put it in there.
So this is just for Android?
Yeah. And so React Native on Android uses JavaScript core by default. I remember sorting that out back then. But maybe this is a variant of it or something else that's faster. I don't know.
Didn't you say, Mike, that at some point in the past, I seem to remember you saying that Facebook had to buy a license for it, or they did some kind of support agreement for this? So maybe they want to get out of that as well as kind of, improve performance.
It is true that when they used JavaScript core, they mentioned licensing it, which I thought was a little weird, but maybe they wanted to make sure they were doing the right thing. Yeah, maybe it has something to do with that, but it looks like it's really a performance thing, which is kind of odd because JavaScript core is fast. But I think, I do know that if you dig into that, you'll see that what they're doing is they are AOT compiling the JavaScript down to the bytecode representation, It's the same stuff that Lumo does. Like Lumo basically is a snapshot of the heap or whatever you want to call it. So it just loads it into RAM and goes,
So it's like a VM snapshot.
Yes, yeah. Like save Lisp and die. That kind of idea.
Okay.
I think that's part of what's doing. Yeah.
Isn't that the kind of thing that they do in React in general? Is they try and like create the pages on the server side and then serve essentially the snapshot pages in the client. You just then rehydrate it and then bam, you in the background they start running all the JavaScript stuff. So all kinds of tricks to make things appear fast when they're kind of intrinsically slow.
Yeah, I guess so.
It's all tricks all the way down.
I know that the app that we have on React Native it doesn't do much, so it doesn't have a performance problem. But I guess you could argue that maybe launch latency could be important for any app, right? You want it to start going quickly. And that's for us, for in the ClojureScript world, that's one of the things that that advanced compilation still gives you is lower latency of startup. So if you don't really have to do advanced for React Native apps to save on space so much, because it's in the binary, it gets downloaded. So what?
Yeah, a couple images and you're already blowing your budget. Yeah.
Yeah, exactly. But I think last time I timed it, you could get like an app launching in maybe like say like 2 seconds instead of 3 by doing advanced instead of simple. And that's just because there's less JavaScript to parse when it starts up. So advanced, is all about making it small, and that still helps with launch latency if that's what you're after.
2 seconds still sounds like a long time.
Oh yeah. I think that when I was timing that was on slower, older iPads that I had, just to kind of force the issue. On a modern iPhone 10, you can launch a React Native app in like half a second or so. It's not an issue.
I think the iPhone
apps?
10 is like more powerful than most desktop computers.
Yeah.
Yeah, so there used to be like all these tricks you would play with trying to make mobile apps look like they're launching quickly, right? Like one thing that you could do if you really get into it is you can when your app goes into the background, iOS can take a snapshot of the screen of it, and you can save the state of your app, and then so that when it's relaunched, it shows that image right away, and then your app starts up behind it and it fills in. It's like all those tricks used to exist like 5 years ago, or they were applicable 5 years ago. You don't need to do so much of that stuff anymore. It makes your app really complicated to try to do things that way. But I'm definitely into performance. I want my app to launch quickly. That will bug the hell out of me if it takes like 2 or 3 seconds to launch.
I know a lot of.
Sorry, the videos on one of the developers' Twitters. He posted some videos of the Hermes engine working at the Chain React 2019 conference, and they're pretty convincing. Like the launches, everything just moves so much faster. But you're right; it's hard to tell. Like, is this dynamically loaded? Are they like? Is there? I mean, you assume it is. You assume there's no caching involved here. But I'll post that in our Google chats. People can look at it.
I've always wanted to do that for JavaScript core, to make it so you could save an image of your currently running state and then just reload it. It'd be kind of nice. V8 has that capability, and I've been envious of it because I like JavaScript core. That's what I want to use.
It's also it's so bizarre to me. Like all these different layers we're adding on top, and then like kind of backing out and replacing something underneath so it's faster. Like maybe if you just remove the number of items in your stack, it would actually get.
You're talking crazy, man.
Oh man, yeah, I know.
Simplification. We could add more layers, caching all throughout.
Yeah.
I think you have to be careful. I think to your point, maybe Derek, is that it's an interesting question as to where does performance sit in our considerations. I think if you're like Mike, if you're working on the compiler, then I think it's super important for the compiler to be fast as possible. But I think if you're a ClojureScript or a Clojure developer, I don't think performance can be your primary goal. I'm not saying it shouldn't be. The performance should be terrible, should be decent, but it can't be the first thing you think about. Otherwise, you're using the wrong language, really.
Yeah, you might as well be writing an assembly then if you're really that obsessed with it.
Yeah, or I think often maybe something like if you go with Rust or something like that or whatever, it's a lot of it is to do with ecosystem and expressiveness and all these other kind of things, isn't it? Not just the raw performance.
A lot of the complaints that people have with React Native for Android in particular do revolve around performance. Like the React Native Android apps feel slow. you can tell when you're using one. You can tell it feels slow.
Okay. Yeah.
So if improving performance could decrease that slow feeling, then it would put React Native on par with actual native development or with some of these other things that people really like Flutter.
Right. Okay.
So I wonder why it's slow. Because I have like a Android device that I got. It's like an old like a Samsung whatever 9. I don't even know anything about these things, but I know that if you look at Replete on it, which is running JavaScript core, it's faster than this modern iPhone 10 that I have. So the JavaScript engine that's in this thing hauls.
I wonder if it has to do with there being less standardization between different Android devices. So they might be slower on some Android devices and faster on some Android devices, depending on the device you have.
Yeah, there's really low-end ones. Yeah.
Yeah. I'm not. My husband's the Android guy. I'm not. So, but when you don't have that standardization, you end up having different loading times on the same thing.
That's a good point. Yeah, it's greater variance of performance capabilities in these devices. Yeah.
Right. And so much of the optimizations, I'm sure, are like, oh, we have so much RAM these days. Let's trade RAM for speed, and if you don't have the RAM, it's actually slower.
But maybe it's also, I'm guessing that Mia is spot on because, she generally is, but also on this occasion, it's for Android. It's there must be pain. Facebook wouldn't do it randomly. There must be the market for faster versions of React Native on Android must be quite big, because why would they put the engineering effort into it otherwise?
Right.
Well, there's competition also. I mean, Flutter is new and people love Flutter.
Yeah.
Right. There's also Kotlin that is coming in on the Java side. People really like Kotlin for native development. And I think Kotlin's a Google app, or Kotlin's a Google language, right?
No, it's from IntelliJ.
Yeah.
Oh, that's right.
Google supports them officially, but it's not.
Yeah.
Yeah. But
JetBrains, actually. In JetBrains, isn't it?
There's competition. So that might have something to do with it also.
It's weird that people want, all these big companies want them on their platform. It's not, this isn't Facebook's platform, their main advertising platform that they have. It's their development platform.
Now, why would big companies want you to use their proprietary software?
Yeah.
Yeah, but it's definitely an arms race there, I think.
Yeah, I think if you wanted to take a less kind of cynical view of it, there's also the fact that, which I by the way, I'm very cynical with Facebook, so fuck that.
You're cynical with everything.
I think, yeah. But I was going to say, a slightly less jaded view of it is that, JavaScript and these are languages. They themselves, the company themselves, need a raft of people to program their stuff on. So they need to make their languages. They need to use generic languages, and then make their platforms faster for those particular devices. But they want to make their frameworks open source, and they want to make their frameworks available and use general languages or push languages out that can become standard. Google wants Go to be standard somewhere, not just on its own platform, and Apple wants Swift to be a thing, not just on its own platforms, because they want more programmers in that ecosystem. Objective-C was too small, blah, blah, blah. Anyway, yeah, I'll shut up now.
Well, for what it's worth, the ClojureScript compiler unit tests pass on this new Hermes engine. So feel free to use it. It's not it actually works. It's only 0.1.0, so yeah.
Can you use it via Renatal, or is it some other? How do you kind of get access to it from ClojureScript?
Oh, it looks like it's down in React Native. You just kind of turn on a flag to enable it.
Right. Okay.
There, you don't. I'm assuming.
So, also, does anyone know what they're doing to get it to be so fast? I mean, besides the whole trick of it's basically already pre-parsed and compiled. is it just because it's smaller? Is it just like a very straightforward JavaScript implementation, and that actually does pretty well these days? What is it?
Yeah. If I wanted to guess, I would say that they've forked existing JavaScript virtual machine and just added some tweaks to it. But, I don't know the technical details.
Yeah, I have to speculate.
Yeah, okay.
Yeah, the only thing the README says is it features ahead-of-time static optimization in compact bytecode.
Sounds good.
Fits and RAM.
Right.
Yeah.
Unless it's like the Graal thing and it like defeats your dynamic stuff. But in ClojureScript, we're using advanced anyway, and everything's pretty standard.
React Native. Everyone who does React does all sorts of dynamic stuff, right?
Mm-hmm.
Yeah. Maybe it's smart enough to like de-optimize in those cases. Yeah, I don't know.
I mean, if they can solve the React Native for Android problem, I think that React Native is already a competitor. I think it'll just get a lot bigger.
Yep, I'm just trying to find some docs here about what it does. Okay, well, we can move on. Mike, you said there was something about intrinsics.
This has been my favorite game these days. So I don't even know if you know what these are. There's one that's in the ClojureScript compiler now that's always, well, it's been there for a long time, surrounding not. If you use the not, I guess it's a function, right? And what happens in ClojureScript is when it goes to like at the compilation, at the back end of the compiler, when it's spitting out the JavaScript, at that point it says, hey, I see that you're using the not function. And what it does is instead of calling the not function, if the argument of the not function is known to be a Boolean through type inference, it puts the little bang in JavaScript. Does that make sense? So it's like an optimization, because calling the not function just to negate a Boolean value is kind of overkill, right? So the not intrinsic, if you will, has been in there for ages. Recently, a new one landed on master in ClojureScript surrounding the count function. It's kind of a similar idea. And if you think about it, if you're trying to let's say you're trying to count the length of a string in ClojureScript, if you call count on it, that will give you the length of it. But there's a faster way to get the length of a string, much, much faster, which would be to access the length field of that string directly. So if you really...
Instead of going through a function overhead and
exactly,
then some kind of type dispatch in there.
Mm-hmm. Yeah, because if you look at what the count function does, it's like a cond inside there. Mm-hmm. And so not only is it a function call, it's like it's a type dispatch built on cond.
It's a branch.
A branch of logic, yeah. And it says, oh, is this thing... does it implement I counted? And then no, is it an array? Is it a string down the line? And you're just trying to get the length of a string,
Right.
So that's an example where it just bugs me. Every time I see the count being applied to a string, it's it just bugs me because I know.
Well, but then do you need different count functions for strings than for, say, arrays?
So you can use .length on an array as well, right?
Okay.
Yeah. So what the count intrinsic does in this case is that if it knows that it's a string or an array through type inference, then it just then at the back end of the compiler, instead of calling the count function, it says, hold on, I know what I can do instead. I can just do .length.
Okay.
So it's like the compiler is smart enough to do what you would have done if you were really obsessed with performance and trying to make these little minute optimizations. So that's on master now. So it's little micro optimizations that you probably don't really need, but hey, if the compiler can do it for you for free and make more optimal code, then why not?
So this isn't a. So I can imagine two ways to do it, right? Where you have this, you have multiple definitions for count.
Yeah.
Right. Where you say,
specialization.
Here's the dynamic one where you don't know what you've got. Here's this big cond. of different types. And then there's another way, which is, or then you have different definitions for each of the different types, where you can, if you know it's one of these types, just replace, call that one instead. Or here's the code even to emit.
Yeah.
But then you could also imagine doing it a different way, which is, I think the way the Clojure compiler, the Google Clojure compiler works, which is just with peephole optimizations, eventually it'll get optimized away. So you inline that cond, right?
Yeah.
And then because of type inference, you can, at static compile time, determine which of the branches is going to run. And so you eliminate all the other code.
Yes.
And you just have the one branch, you don't even need to check at runtime.
So sometimes that definitely happens. Like you might make an optimization like one of these, and you'll do that only to find out that Google Clojure is doing it for you already.
Right.
Yeah. So you have to be careful not to like waste your time trying to optimize something that it's going to optimize for you.
Right. You're better off like just adding smarter type inference for the Google, because the Google Clojure compiler uses the same type inference information that you're generating, right?
We don't. Yeah, the ClojureScript compiler does not put the types into the output for it to use. And as far as I can tell, it doesn't even have much in there at all, even to look at types if you were to put them in there.
Oh, okay.
It seems like Google Clojure uses types mostly as a type safety thing, like for type checks, to help you avoid errors in programming, rather than for optimizations.
Okay.
Which doesn't make sense to me, because it's like, if you knew type stuff, you could really leverage that to make assumptions about the code that's being emitted.
Right.
So you're saying types are good?
Types are good for performance. Is that crazy to say? Am I going to be kicked off the podcast now?
You're going out of here.
Yeah,
Get out.
You're out of here. Yeah.
I like types personally.
Yeah, just in case you didn't know, ClojureScript is a typed language in a sense, because it's got type inference in it. Yeah.
Types are good.
Types are. Oh no, does it? Yeah. So anyway, I've
personally, I'm typist.
So like you said, Eric, if you wanted to, you could write specific functions that are catered towards certain types. And one example of that is the function called keyword identical. It's kind of like a faster version of equals in ClojureScript. But if you know that the things that you're comparing are keywords, you can say, oh, let me call keyword identical. And it truthfully, what it's there for is that you used to be able to use identical on keywords in ClojureScript, just like you can in Clojure.
Because they
used to actually be interned, and then at some point that changed, and they're no longer interned. So to make up for that, you had this new function called keyword identical. But what I think how
is it faster? Like, what does it do?
So since it knows, if you look at equals, it's the same kind of story. It has to say like, oh, are they identical first of all? Yeah, then they're equal. If not, then go down these branches.
Right.
And keyword identical,
just like exit early.
Yeah. So what keyword identical does at its guts to make it as fast as it can be is it pulls the fully qualified names out of the keywords and then compares those strings with each other to see if they're identical. So it kind of lifts that out of there and then does identical on the strings.
Okay.
So anyway,
a lot of to get around to eventually, it just skips all the branches.
Yeah. So another intrinsic field that I've been playing around with is like like people will do this by hand. Like if you're obsessed with performance, you're like, I can't compare keywords with equals. I'm going to go put keyword identical in there. Well, the compiler can do that for you. If it knows that both arguments are keywords, it can say, oh, I'll do the same trick. At the very last second, I'll admit this call to keyword identical for you. So then you could just write your code in a nice, simpler way. Just use equals, and let the compiler optimize that case for you.
What percentage of code, or like let's say code points in a project are now have types? Like that can be inferred.
So
do you know what I mean? Do you have a metric?
Like if you imagine like all the points throughout your code base, like if you said, is this thing typed? Is that thing typed?
Yeah.
Well, I think like if you have a function and the parameters come into the function, you start off not knowing the types there. And it's only like if you hint it that you'll get a type that way. And a lot of the places where you get types is like the return values of functions that you might call inside your function. Like if you let bound something to something, then you're like, oh, if you call like the name function, the output of name is going to be a string. Therefore, whatever you use that in, now it's a string.
And and you're doing also like flowing types from like if statements with predicates. Is that right?
Yeah. So yes. So if you have a test and you say if string question mark on X, and then you use X inside there, you as a human know. Yeah, and the compiler also knows that thing is now a string. Yeah, because it's satisfied that predicate. So these are just little like once it's like type inference is there, and these intrinsics that you can play with kind of leverage the types that are known. So another example is if you know that that the value is an indent, either a keyword or a symbol, and you call name on it, you can get rid of that name function call and replace it with a thing that accesses .ns directly. Same. I'm sorry, with the .name field. Same. Yeah, and if you're calling namespace on an indent, you can just replace it with .ns.
It just seems odd that like that wouldn't get compiled away in some layer in there, like in the JIT of the end of the JavaScript engine, or with Clojure.
I think you're right that it can. There's a possibility that it might, and then the only way to find out is to try it and run it through advanced
for your particular code.
For your particular engine, like Node versus JavaScript core, and whether or not it's clever enough to see it and make the optimization itself. Yeah.
Right.
So I think that's really the game, is like you're just you're throwing it a bone, right? You're saying, here, I'm going to make your code a little bit easier to deal with, and just kind of like optimize for it. And then that enables a whole bunch of other optimizations that kind of cascade, because now instead of calling a name function, you're just accessing the .name field on this object.
Right.
And it's like, yeah, that's just, it can't do everything. So you're just trying to help it a little bit, Yeah.
I remember one technique that they were using. I don't know if they're still using this. I haven't kept up with the JavaScript engine optimization stuff. But one thing was they would bubble up conditionals, especially type checking conditionals. So they would compile like if you keep checking, is this a string? It would move if this a string up to the top, and then have separate branches. Straight line branches of code for each type. So that there's no branching. It's just super fast. They can pipeline the thing, and it seems like that's an opportunity there that you could do in the compiler.
Yeah. There's all types of things you can do once you know types. Once you have like static information.
Yeah.
Types of tricks.
Did you see that that thing? I didn't follow it completely, but there was a thing today or yesterday from Tonsky about Clojure and Rust, and Rust was like 17 or even 30 or 40 times faster than Clojure.
Yeah, I saw that.
For the same amount of code.
It's hash algorithms or something that it's doing. Yeah.
For the same amount of development time?
For the same number of lines of code, basically.
Yeah.
So it was kind of. I think what he was trying to prove was that he could. Without too much code golfing, he could. We were talking about why you choose Clojure, expressivity, brevity, those kind of things, maybe. And if you can find a language that goes, 20 or 30 times faster, then maybe that makes the language more attractive,
But expressivity and brevity are not always the same thing.
Right.
No, that's fair.
Usually not. Not usually not, but they're totally separate concerns. Was the more brief Rust code as expressive? Was it easy to read and explain?
That's definitely what should we say? Eye of the beholder, kind of. I'm not sure how we've got fantastic metrics for those things, but Yeah, according to him at least, it was still quite nice. You know.
I know people really like Rust, and the mascot's very cute.
Oh yeah, that's the winner. Yeah,
That's important.
Well, but it turns out that apparently it was to do with boxing and unboxing numbers. That's the fundamental problem. And we had a chat recently with the guy that does the CLR version of Clojure. This guy. David, someone. Oh my God, he's going to kill me for this. But
shame on you, Ray.
Such a lovely conversation as well. I'm like, God
What he was talking about.
Anyway, my point was that is that with the JVM, the number of boxing and unboxing operations is limited to a predefined set. With the CLR, you can extend that set. So he was saying that that's one of the things that he's going to do with the next version of the ClojureScript, of the Clojure compiler for .NET, is extend the number of unbox operations, because the people that do the Arcadia game engine, that's essentially what they do, is that they take the compiled code and then they rewrite it to get rid of the unboxing. So that's how they get the performance benefits for Arcadia. Is that and apparently it's like, again, like, well, you know, like Tonsky claims, you know, it's like 17, 20, you know, it's actually usable. It's you know, for a game engine, you need that kind of optimization to make it work. So that's what they do, and because you have that freedom, if you like, in the CLR that you don't have on the JVM. But apparently it's coming in the JVM. So this is going to be interesting. That you know, in the coming releases, they are going to expand the number of, or expand the freedom to unbox more things yourself. So for generics and stuff like this. My question, actually, regardless, I mean, that's just an education piece, but my question is, what does the JavaScript stuff do with boxing and unboxing, Mike? Maybe you have a view on that.
So there are primitive numbers, right, in JavaScript, and you know, when you're passing them around to all these functions, you're passing those primitives around. Like ClojureScript does not put, like, you can create a number object, right? But no one does that kind of stuff, right?
Right. Same with something like string. So my understanding is if you make a string, it's just some native representation of string, but then you can modify the string.prototype, and what that does is it totally throws out, now it has to use an object each time you make a string, and so it just really slows down your code because now it has to box every string.
Well, I mean, the example for the numbers is the coordinates. So you have two numbers, X and Y. So then how do you deal with that in JavaScript is the question, because, you know, you've now got essentially an array of two numbers, or does that just flow through, or is that?
You got the pointer to the array, and then the array has pointers to the numbers, and it slows everything down. I don't think there's any way. Like, I know that they're talking about doing something for that, for the you know, a solution for that on the JVM with value types, where they're essentially not reference semantics, they're like copy semantics. So when you pass them, because they're immutable too, so you pass, you know, this instance to a method, it actually will copy them onto the stack. Because they're read-only, and that's much faster than having a dereference, right? Each time you need to read it. Also, you could make an array of them, and it will be instead of an array of pointers to these objects, they're all in line in the array. So when you load it in memory, it's like the whole, you know, everything you need.
Locality reference kind of.
Because that's a huge performance win.
Yeah, huge. Yeah. I mean, another performance problem that Clojure runs into, besides just boxing and unboxing, which is big, but there's also, and it's kind of related, it's the generational garbage collection that totally blows your cache. You know, if you didn't have all this garbage, even if it's collected in like 3 instructions, like almost immediately and reused, it's blowing your cache each time you're
putting too much pressure on the memory system.
Yeah. And it's just because the garbage collector is somewhere else, you know, and so every time you need it's just like removing it out of cache and loading the garbage collector and then loading your code back in. It's really slow. And if you could have some solution for that, which I think Rust has, right? I think because it doesn't do garbage collection.
Yeah, they have borrowing semantics. Yeah.
Yeah, like it knows exactly when the object cannot be referenced anymore, and it's just, you know, it can just let it go. Like it doesn't have to walk a graph of objects and figure out what's still free. It just lets it go. Which is, you know, that's super fast.
The one thing I wonder is like what Ray mentioned with the boxing and unboxing, oftentimes to make some Clojure code run faster, you just need to hint it, right? Hint it with like primitives and whatnot. And what I wonder is like if type inference got better and better in the Clojure compiler, could it and certain places do that for you if it could see exactly what the code is doing? I think
it's a Java VM limitation, that one though.
Well, so like you can, as a human, you say, I know exactly what this code is doing. I'm going to put some type hints in there to make it deal with primitives. And my argument is, if the compiler were smarter and could actually do the same analysis that you as a human is doing, it could put those hints in for you.
Well, it's funny you mentioned that. Here's a good example of that kind of thing. You know, Zach Tellman has a library that has a different model of persistent data structures from what we use in Clojure. He has the idea of, I'm going to get the terms wrong, but there's a linearized versions, which means I'm not sharing this code with anything but myself, just in a sequential linear access kind of way. And then there's the parallelized ones where I'm sharing it now, so it has to be
truly persistent or whatever. Yeah,
it has to be like I have to copy before I make modifications.
Okay.
And so it's immutable. But what's interesting is in the iterative linear case,
like transients,
a mutable thing because your thread is the only thing that has access to it. And Bodil Stoka, she used to be big in the Clojure world. She's now doing this in Rust. She ported this idea to Rust and has some really fast persistent data structures that use this model, and it uses the borrow checker to know when you're in a, you know, you can't, if you're using it in a linear way, you can't share it, right? So you have to convert it. The type checker can tell you, yeah, you got to convert it before you do that. And so they're really fast because it's a mutable thing that, like, you know, can fit in the cache basically. And then when you share it, boom, it then converts it into this immutable thing that can be shared. And the secret is that the type checker can guarantee it. Whereas something like transients in Clojure, it still has a lot of semantics about like forcing you to use them in this linear way. Like when you make a transient and you like assoc onto the transient, you can't use the old version, right? So there's a lot of objects that get created, allocated to make sure that that's happening. And this way, it's all done through, you know, static analysis.
And then that doesn't overload your garbage collection.
Exactly. It's all, I mean, that linear thing where it's super easy to analyze and you're just doing, you know, adding 20 things, 2,000 things to this hash map, it's really fast. And then, boom, you share it out and it's immutable. So it's fast because of that once you do that.
Yeah, but I mean, you're basically, you're never in a situation where magically things become like, you know, shared, unshared. It's always expressed in the code somewhere. That's what you're saying, isn't it? Is the compiler will tell you ahead of time, "Ooh, you're trying to use this thing in a shared way, so now we're going to have to emit different code."
Yeah, like the compiler could do it.
It just gives you an error. It just says you're trying to share
using
this
it the
linear
wrong way.
thing.
Yeah.
You got to call this function on it and share that thing.
Yeah.
So it's not magically changing it for you, but it's essentially just telling you what code to put in.
Yeah, so like if you create a new hash map and you associate a whole bunch of things onto it and it hasn't escaped the function that you're in, the compiler, if it could turn that into a transient for you and make it faster. You know, it's all just a matter of how smart the compiler is and what it can pull off doing the things that you as a human could do instead, you know?
For sure.
Yeah.
Yeah, I mean, there's so many things you can do. If it's
so there's a lot of more water you can wring from this stone. I mean, it's
But I think the general idea of, maybe I'm wrong here, but my understanding is the general idea is that for Clojure at least is that you put things in a situation, and ClojureScript for that matter. I think general design is put things into a situation where the underlying engine can optimize it. Don't do too much yourself.
Definitely, yeah.
I also think there's a lot more room for exploring speeding up dynamic languages. It's there's an interplay between the static and the dynamic, and we should be looking at more ways of, even getting more expressivity because we're dynamic. Just blow it out and just say, look, computers are getting faster. We're just gonna.
Well, I think one of these things is if you're not, I think it would be I think the Graal VM type approach is that if you're not actually using this dynamicity, whatever you want to call it, if you're not using that, then don't worry about it. Just make a static make a static version of it, compile it down, and that's one way. That's one answer, isn't it?
Yeah, and that's quite often in a small piece of code, that it's not dynamic, and you can analyze it and you can arrange
especially
really
for CLI type things. If
that's interesting.
A server, it's a bit different.
So if the .NET guy figures out how to do boxing in a better way, maybe that knowledge could be shared with Clojure. It's like whatever that experiment leads to would be a good thing.
Yeah, I think that's what should we say? It's a feature of the CLR though.
Oh, okay.
So it has to be a feature of it has to become a feature of the JVM as well. Oh, we've got a baby on board. That's nice.
Hello. Just woke up?
Yeah, just woke up.
Got sleepy eyes, yeah.
She's so big.
I know.
Hi. Oh my gosh.
10 months now.
Hello.
Sorry to derail the conversation.
I know we were deep on
the apropos baby,
Oh, do you want to talk about Clojure?
I don't know.
No.
Her dummy has got kind of parentheses around it. Is that deliberate, Eric?
I should get her a Clojure onesie. That'd be pretty
yeah.
Hi. All right, shall we REPL?
It's time.
It is time.
Hi, what's her name?
This is Isabella.
Hi, Isabella.
Should have combed her hair, huh?
Everyone becomes completely incoherent, and the baby appears, and there's just...
What were we talking about? Yeah.
Who cares? Optimizing something?
Yeah, something. Yeah. She's like, yeah, when I start using computers, it's not going to matter.
I know.
I'll be so faster then.
I don't know.
Can I just say, by the way, before we start...
I remember I had just said that they're getting faster, but maybe they're not anymore.
Speed of light. Yeah.
We're just going to have to use more of them.
Well, that's even, will there even be computers,
Will there even be computers? Yeah.
Will there even be,
energy to run them?
Collapses, yeah. what's going to be left.
Dark energy is going to take us over.
By the way, just for politeness, it's David Miller who does the CLR stuff.
Ah, okay.
Okay.
And he's an absolutely top bloke. So,
Wait, isn't he like the only one working on that?
I think he's had some input from some other people, but yeah, I mean, he's been the lead developer of this thing, plowing a lonely furrow for like 10 years. Yeah. We had him on the Def On podcast, and guess what? He'd never spoken about it out loud to anyone before.
What?
I know.
For 10 years. He's just been slaving away in his basement. Oh, no.
But, he's the dean of a computer science department in a film school. So, he's like, he's an amazing character, actually. Anyway, different. I don't want to hijack that, but go listen to the podcast if you guys are interested in that stuff.
I'm curious because like Clojure started off supporting the CLR, right? Initially.
Yeah.
And then that was dropped, I guess, at some point. And
Yeah,
David Miller took it over. Yeah.
David talked to Rich about it, but yeah, it's been like you say, it's been like a pretty lonely furrow there, but they've got a few people using it now, and the Arcadia stuff has put some new interest on it. So, oh man, look at that! Oh, who's the funny man?
Something important to say?
I could go. Clojure on the CLR.
Thousands of people. Millions, maybe.
Millions, yeah.
Actually.
All right. I don't know if we're going to do the REPL, are we?
Let's see.
It's kind
What else
of
do we have on our list? Yeah.
Well, we have
couple of things.
1.10.1.
We've blabbed on quite a long time. Could be just a chatter.
Yeah, we could take a pass on the REPL this time and then finish out the few things on the list.
Yeah, the baby will suffice.
Yeah.
Correct.
Learn how to baby. Oh man, she is super cute. Yeah.
Oh yeah, sorry, Brian. We put the poker exercise from last time in the show notes, but we've been distracted by the baby, so we're probably not going to work on it today.
Yeah, life happens.
Yeah.
I mean, how can you do a REPL? You have a cute baby.
Yeah, Eric, make a noise so the camera switches to the baby.
Yeah.
Okay, here. Look at this. You're cute.
Hi.
This is going to make our podcast pop right here.
Hi.
So, the only Clojure show with a baby.
Now I had a lizard before, now a baby. Oh, man.
So what is new in, what is it, 1.10.1?
Yeah, wasn't there? It was a bug or something that was making it really slow using. I don't know. I can't remember like Java.
The user space, I think it was the.
Yeah, there was some change in the JVM that just made startups real slow.
Oh, I remember this. Okay, so they fixed it.
The files, I think, like Mike.
What's that?
I think only for people with big user files like you know.
I think I was the person who discovered it because I had just gotten a brand new computer and I was like trying it out and all of a sudden it was so slow and I was like, what's going on? And it was because I had installed the newest Java on that box and I was like looking at my older computer and it was faster. The older one was faster.
Actually, I wonder if that's what's going on. A couple of our devs have new computers that are slower than we thought they were going to be.
Yeah.
So we should take a look at that.
Make sure they're running the latest Clojure. Yeah.
Yeah.
Yeah. It happens if you have stuff in your user CLJS or user CLJ file, which React Native apps by default do, evidently, and that's where I noticed it. So if you have a new computer and you're doing React Native, and that's when
and 1.10.1 fixes all of this.
Yeah.
It says the issue may eventually be resolved in Java, but in Clojure, in the meantime, they've modified runtime initialization to avoid loading user CLJ in a static initializer.
Really subtle, whatever's going on there.
Yeah. And then they also just kind of threw in some new error reporting in Clojure.main.
Yeah. What I want to know is, when is Spec 2 coming out? Come on, get it out.
It's like Ernest and Julio Gala. It's not going to happen.
Apparently it is in alpha, because I spoke to someone recently who said they're using it and they've tried it out. It's in alpha. It's looking good. So I don't know if that's going to be a 1.10.2 or...
So Spec came out in 2016. Is that right? It's been in alpha since then.
Wow. Yeah.
So now Spec 2 is alpha.
Yeah. Everything's going to be in alpha soon.
Yeah.
Yeah.
I know a lot of people want courses about Spec from me. I keep saying, like, if it's in alpha, I can't do it. Like, it's going to change.
Yeah.
So,
but I think it's a messed up situation, because they put it in alpha, but now it's so long in alpha that they can't change it, because there's too much code running on it. So they have this like new namespace, which I don't know if that is actually an alpha, but I mean, it's like there's an alpha build of Clojure with it in. I don't know what the official naming or kind of status of that Spec 2 is, but it seems like it's getting baked, so
everyone uses it.
Right.
It's quite exciting to get to a point where Spec, some version of Spec at least, whatever you call it, Spec X, is actually non-alpha. That would be really good,
Yeah, it's basically not alpha anymore, just by virtue of having been adopted so widely.
And they stopped development on it, really, like new features, because they started on 2. But it's one of those weird things where if they hadn't released it and people hadn't started using it, they wouldn't have realized the problems with it. So
it's a catch-22.
Yeah.
Yeah, but I think it ends up being a bit like a blockchain, in the sense that you kind of like, you have to fork the whole thing, which is what they're doing with Spec 2. So all these people that are using Spec now are basically kind of like living in classic mode of Ethereum. They're I don't know what the hell's going on with those people.
I have no idea what you're talking
about. Yeah,
okay,
let's leave that alone. Yeah, kind of like.
Would it make you happy if they just called it Clojure Spec and released it? And
it would make me super happy. Yeah. And then
Spec 2
they can call it Spec X or whatever they're going to call it, but just get rid of the alpha, then Eric can do his course, and we can build tools on it, and life can be good again,
Yeah. I don't know. I think they also need to release some guidelines on it. I personally don't use Spec that much, so like I don't know how it's supposed to be used, but when I do follow discussions, they're usually someone asking, how do you do this with Spec? And Cognitech saying, well, actually, you shouldn't do that. That's a different tool, right? And it's like, well, what are we supposed to do with it then? There needs to be some guidelines on it.
Well, yeah. I mean, hopefully with this Spec 2 thing, it will be a bit clearer.
Yeah, I mean, like part of the whole alpha thing was seeing how people were going to use it if you didn't give them guidelines. And the answer is for a lot of the things that you sort of want types for.
That's right.
Actually, didn't someone, I think it was Matosin, actually just came out with another thing that actually is between Spec and schema. So, because I think that's one of the other problems, is that people want to use like schema type things for coercions and stuff like that.
Yeah, it's brand new.
Like Cognitech, they're saying, well, we don't want to do that. And sorry, Mia.
It's called Mali.
Oh,
it's
really?
like, right? Yeah, it's brand new. It's pre-alpha in design and prototyping phase. So Daniel Compton mentioned it in this week's REPL. Because, a lot of people miss schema. But yeah, I think that having a standardized spec that is actually the official spec would probably put a lot of this proliferation to rest.
Yeah, or people, if they want to make a tool that does coercions and stuff like that on top of it, then they can. But it's like, okay, but that's the schema thing. That's what that does. And then that's what spec does. And then if you want coercions and things, you do it like this. And blah blah blah. You know, all the tools can live on top of it or aside of it. But yeah, I don't know why this. I mean, I trust the Matosin guys to be quite smart, so they've been working with spec and schema for a long time, and those engineers are doing a lot of good work. So it will be interesting to see what they come out with. Because one of the things that I find, by the way, is that, you know, we're kind of like hitting against is that spec is fine for like speccing out data packages, etc., but integrating it with like REST endpoints and putting, you know, versions of APIs against particular specs, these kind of affordances are missing completely, and that's okay for them to be missing from spec, but we need some tools on top of spec that we can kind of trust.
And it's scary to build tools on top of spec when spec is in alpha.
Exactly.
Yeah, I mean, I've seen people use spec for the case that they used to use schema, which was, we want to totally ensure that messages we get look a certain way, like have a certain structure, have certain.
I think that's a great use case, personally.
Yeah, and so it's actually, when Cognitect talks about it, they say, oh, you shouldn't do that. You should just check for the things that you need, that you know you're going to use, and not, you know, if there's extra keys in there, let them through.
Right.
And
okay. Well, that's okay.
What's that?
I think that's okay as well.
Yeah, I mean, it's a good use case, but there's also, because it allows for future expansion of your API, right? But there's also the case where someone is writing a new client for your API, and you kind of want to be really strict with them. You want to say, look, this is how it looks now. If you're giving us other keys, you're doing something wrong. Like, there shouldn't be anything else there, because this is the API right now. And so it's sort of like you're using error messages as to teach your API consumers like what values to send it. And this happens a lot when you misspelled the keyword in your map on an optional key, and now you don't get an error message because it was optional. So it's just like you left it out, but it didn't check that you had this weird key that it didn't recognize, because that's what it's supposed to do. Yeah, I understand there's these like two use cases. Like, there should be some flag you set, like, I'm a new user of this API, please be super strict, don't let me do anything weird yet. And then you turn it off when you're like, okay, now I'm going to be sending you like future versions perhaps of this document type.
It looks like we have a birth announcement in the chat. So congratulations, Simon, for becoming a dad 2 days ago.
Yeah.
Oh, yeah. Congrats, Simon.
Yeah, it's like the spec survey isn't done. And you have a lot of people who are doing things with it that we need tools for, and spec might not be the tool for it. But
sure.
I think a lot of people have, I mean, I'm going to put it in a bad way, in like an ungenerous way, but they have type envy. They're trying to do types with spec.
Yeah.
And I'd love to see explorations like of something else besides that, like some other thing that you couldn't do with types that we're able to do with spec.
I think the other problem, to be honest, with spec that they're trying to address with the spec 2 is the fact that, I mean, spec needs to be, and like I think in Clojure in general, it needs to be more programmable. It needs to be like this notion of being able to like detect the keys and run, like what is the spec that what is the spec that was used? Give me back the spec actually that I'm saying is valid.
Yeah,
this is quite nice.
More data driven, basically, instead of a bunch of macros.
Yeah. I mean, like there's also good like spec error reporting tools. Like explain info is great. or is it explain data? I always forget, but it's one of those, and that does give you back a lot of what you want. But there's also like there are a lot of different explain why the spec failed tools that there's almost too many, and they take different arguments.
Hey, Ray, test check is taken to come out.
What's that?
Test check is another one that bothers Ray for how long it's taken for it to get out of alpha.
It bothers me. Yeah,
it's been in alpha for like 5 years now.
I find test check to be pretty stable though. Like maybe 5 years they should take it out of alpha. But is something missing?
It's coming out of alpha now. It's coming out of alpha.
Okay.
All right, I've got to go. I've got to prepare for my next meeting.
All right.
I think she's saying, wrap it up, guys.
Yeah.
Come on.
Time to wrap it up.
All right. Okay. Goodbye, everyone. We will see you all in 2 weeks, probably.
Bye.
Oh, man, she's giving you the big smiles there.
All right. Bye, y'all.
Bye.
Bye.
So,
I think we bail at this point then.
Yeah. Thanks, everybody. Don't forget to like and subscribe and share and all those lovely things that help us reach more people. Cool. See you later.
Later on.
Bye.